Years ago, an ancient people came here. With care and skill, they crafted 3 great monuments and then passed on into the obscurity of history. Little remains now. Cut sandstone aligned to the stars. In isolation, there exists a curious object resting on a low platform. Throughout time, it has always been called the Comet Stone. Years. The technology has changed, but not the vision. We are but a part of this great solar system. We share one thing in common with the planets, moons, and the solitary star we call the sun. In the most literal sense, we are the children of the dust from which this system was formed. We are restless, inquisitive, and always searching. This is the year of the return of Halley's Comet, and a new adventure is about to begin. This 960-kilogram European spacecraft, named Giotto, will cross 685 million kilometers of deep space to attempt a close encounter with the enigma of the comet. It will be a journey into the heart of one of the oldest and least comprehensible objects in our solar system. A journey back in time. For Halley's Comet is more than a curiosity. It may be a relic from one of the most profound events in our history. Four and a half thousand million years ago, a giant molecular cloud drifts through the vacuum of space, its origins unknown. A small part of this vast cloud begins to collapse. Hydrogen fusion begins. Energy is released, a phoenix rises, and a star is born. A star we call the Sun. Nine planets and many moons begin to struggle for orbital stability. As the system begins to cool, on the edge of the Sun's gravitational field, a distant cloud of dust and gas are all that remain unscathed. Later, many millions of years later, small objects begin to form, and these will become known as comets. On the surface of one small planet, an atmosphere forms. Within this atmosphere, a strange assortment of self-replicating molecular structures begin to struggle for domination of its surface. Some survive. Many fail. But one species is astonishingly successful. The children of the dust. Yet the journey may have been troubled and disturbed. Every 30 million years, the entire solar system begins a transit through the densest plane of the galaxy. Something causes the magma beneath the Earth's crust to begin to move. Sea levels and temperatures fall. Mountains are formed. Meteorites bombard the Earth. During this period of intense upheaval, many forms of life are destroyed. The frozen remnant of the birth of the sun, the Oort cloud, may also be disturbed. Fragments are thrown into space. One will later be called Halley's Comet. It is only theory. It is in search of answers that we have chosen to explore Halley's Comet. We have watched the comet for thousands of years. From the first time we began to record our history, we have been haunted by this spectre. A demon in the sky. An omen over the battlefield. A source of artistic inspiration. A portender of natural disaster. A subject of scientific study. Its last return was in 1910, and it was the English Astronomer Royal Edmund Halley who correctly calculated that the comet had an orbital period of 76 years. 76 years after the last return, an entirely new generation prepare for the comet in their own particular way.
Wherever you are, station to station, whatever you do, nation to nation, check out the sky, see the constellation. The Earth is getting ready for a new sensation. Scientific, futuristic, fatalistic, techno-terrific. Here it comes once again, and we just can't seem to understand the comet because we're living in a dream. Space well before BC, frightened many people and they tried to flee. Talking about the ice and the dust and grains, the deep freeze history and bring it back again. Straight to the sun, releasing dust and gas, lighting up the present with the future and the past. Traveling with a tale of destiny, leaving us to wonder about the mystery. Let the planet rock, let the light show begin. 76 years till it comes again. So put your eye inside a telescope and you just may see a little hope. A cosmic picture of a shooting star that tells the world where we really are. Now let's party on the planet to celebrate the return of the comet and the end of the wait. Here comes Halley's Comet.
Never before has the return of Halley's Comet been exposed to the full force of mass communications. As the children of the dust prepare, popular television and space technology combine to make certain that this return will be remembered.
Look, here it comes.
But the scientific adventure began 3 years earlier, on the 16th of October, 1982. A charged coupled device attached to the 200-inch telescope of Mount Palomar clears the field. The image is faint and distorted, but it is unmistakable. Halley's comet has returned 8 seconds from its predicted position. The comet is now in the heart of our solar system. A coma of ionized dust and gas nearly 400,000 kilometers across obscures the central object, the nucleus. No comet nucleus has ever been seen, and this is one of the primary scientific reasons for exploring the object. The molecular structure of the nucleus may be all that remains of the original matter from which the solar system and eventually life were once formed. Until the European Space Agency's probe, Giotto, encounters the nucleus, we can only imagine the scene. It is a strange landscape, frozen, boiling, ancient and violent. Perhaps this is the original matter that formed the solar system. Perhaps it is just an intruder from the distant stars. Perhaps it does not exist at all. We simply do not know. 500 kilometers above this terrible landscape, Giotto will pass on the 13th of March, 1986. In French Guiana, European technicians prepare Ariane for launch. Throughout 1984 and the early months of 1985, the European Space Agency's industrial contractors have struggled to ensure that the spacecraft will be ready in time for the launch. It has been named Giotto, after the 14th century Florentine artist Giotto di Bondone, who portrayed the comet as the Star of Bethlehem in his famous fresco, The Adoration of the Magi. The inspiration is perhaps unchanged, but the technology belongs to the 20th century. Giotto is a dual-spin configuration spacecraft that consists principally of a double-shield dust protection system, viewing portals for experimental equipment, and a large transfer propulsion system motor, and a high-gain RF antenna for communications with Earth. Integrated solar panels provide power during its long journey to the comet, but batteries, built into the main body, will power the craft through its 4-hour close encounter. Giotto's design and its launch date have been calculated to take it around the Sun in the opposite direction to the comet. Close to the ecliptic plane, 145 million kilometers away from the Earth, the spacecraft and the comet will meet at a relative speed of 68.7 kilometers per second. Giotto will join an armada of 5 other space probes, the American intercometry explorer ICE, 2 Japanese and 2 Russian craft. It is the Russian probe, Vega 2, that will act as a pathfinder for Giotto, guiding it towards its final act, the close encounter. Giotto's journey to Halley's Comet began in April 1985 in Toulouse, southern France. With the construction and development of the spacecraft completed, it is packed into a sealed container and, together with all its support equipment, prepared for shipment to the Ariane launch site in Kourou, French Guiana, on a specially chartered Air France 747. Included amongst this equipment is a payload of 10 separate experimental packages, a charged coupled device camera to photograph the nucleus, instruments to analyze the chemistry of the coma that surrounds the nucleus, equipment to analyze the plasma that is interacting with the solar wind, and to study the dust particles that are being hurled from the surface of the nucleus. The flight to the Kourou launch site will last 9 hours and cover nearly 7,000 kilometers. Once in orbit, Giotto will have to journey a further 685 million kilometers to reach Halley's Comet. The 2nd of July, 1985, the final countdown. Within 17 minutes, Giotto is carried by Ariane into a geostationary transfer orbit at an apogee altitude of 35,700 kilometers. Before releasing the spacecraft, the launcher begins to spin its payload in preparation for the complicated maneuver that will set Giotto on course for the comet. Tracking stations around the world monitor the progress of the launch. From a geostationary orbit around the Earth, Giotto now uses its own propulsion system to take it into a heliocentric transfer orbit, spinning itself up to 90 revolutions per minute, before settling into a spin rate of 15 revolutions per minute. This maneuver takes up to 5 hours, and once completed, Giotto is on course for Halley's Comet. In Darmstadt, Germany, European Space Agency scientists patiently wait to take control of Giotto. As Giotto begins its 8-month journey, back on Earth, the return of Halley's Comet is becoming a major industry. In 1910, they sold comet pills and gas masks. Now it's porcelain, champagne, and souvenirs. By November 1985, the comet is already visible, an ancient enigma over an ancient landscape. As Giotto sweeps around the sun towards its encounter point, it is traveling at a relative speed to the comet, which is nearly 70 times faster than that of a bullet. Thursday evening, the 13th of March, 1986. Commuters stream home along the fast German autobahns that surround the European Space Operations Center. At the Space Center, Giotto's close encounter with Halley's comet is about to begin. T minus 240 minutes. Giotto is now within range of the massive comet. Telemetry data from the Russian spacecraft Vega 2 and the international Halley watch has been computed, and a minor course correction will now guide Giotto towards the nucleus. T minus 70 minutes.
Thank you.
Giotto now begins to enter the outer regions of the coma. The scientific instruments are analyzing the dust and gas streaming from the surface of the nucleus. A specially installed hotline between Moscow and Darmstadt maintains the links with the Russian craft Vega 2. T minus 10 minutes. Giotto is now some 4,000 kilometers from the bright nucleus, but the CCD camera is beginning to return the first images. Never before has such an object been seen. T minus 0. Traveling at a sun angle inclination of 107 degrees, Giotto is now within 500 kilometers of the nucleus. The elemental and isotopic composition of the coma is being measured, and the data returned to Darmstadt via the Australian ground tracking stations. But the spacecraft is now at its most vulnerable stage. Without warning, the signals cease. The fate of the spacecraft, unknown. Its mission is over, but the comet has revealed something of its secrets.
Yes, because between those two windows, he wasn't able to access data from before that time.
From the stars we came, and to the stars we return, the children of the dust. Travelers in the darkness, searching for answers. It will be months, perhaps years, before we have any real answers. It matters little. We have waited perhaps 4,000 years for this moment. Now, the comet's stone is but a symbol, a tribute to the unfaltering vision that guided us from here to the heart of Halley's comet.